So in this video, we are going to go over how to write the equation of a circle when you're given three collinear points. So 3 points that are not all on the same line. In order to write this equation, you need to find the center of the circle and the radius, and then you substitute those into the formula. First, I'm going to focus on finding the center of the circle. There's going to be a few steps to do this. Let me give you a glimpse at what we're going to do, and then I'll go through each step in detail. So this is from geometry. When you have a circle, if you can make a chord, so that is a line segment whose endpoints are both on the circle. If you can make two different chords, if you find the perpendicular bisector of each of those chords, so a line that is perpendicular and cuts right through the middle of each of those chords, the point where those two bisectors intersect, that is the center of the circle. So what we have to do is find the perpendicular bisector of each of these chords. I'm going to focus first on this chord, and in order to do that, first I'm going to find the slope so that we can find the slope of a line that is perpendicular to this chord. So the slope of this line, if it's drawn exactly, you can just do rise over run. Otherwise, you need to use the formula. So when I'm using the formula, I label my x and my y's, and the slope is the difference between my y's. So I'm going to do 5 minus 1 divided by the difference in my x's, 7 minus negative 1. And then you simplify. So this is 4, this is 8, and that's 1/2. So the only reason we found the slope of this line is because, again, we want to find the slope of the line that is perpendicular to this. So we need to remember, if something is perpendicular, the slope is the opposite reciprocal. So if this one is positive, the slope of the line that's perpendicular has to be negative. If this one is 1/2, I need to flip it. The slope of my new line is going to be 2. So this is the slope of the line that is perpendicular to CB. Now I need to find out, where is it going to start? Where is it going to cut through the segment CB? What is the midpoint? So to find the midpoint between 2 points, all you do is you average your x coordinates. So my x coordinates are -1 and 7. So I'm going to add them up, divide by 2. And then the average my y coordinates, 1 and 5. So I'm going to add them up and divide by 2. So when I simplify that, -1 plus 7 is 6, divided by 2 is 3. 5 and 1 is 6, divided by 2 is 3. So this is my midpoint. If you look at the graph, if we go over 3, up 3, you can see this is the middle of the segment CB, and then this is the line that is perpendicular to it. We now want to come up with the equation of that line. So if you have a point and you have a slope, then you can write the equation of any line. So you use the slope, which is m, and then the point, which that midpoint we found, is our x1 and our y1. And I'm going to substitute those into this point slope formula. So I start off with y. I'm going to subtract my y coordinate on my line, equals, and then it's the slope, parentheses, x minus my x coordinate. And that's it. That is the equation for our perpendicular bisector. Now we're going to do the same for the chord AB, or BA, either way. So the first step is to find the slope of the line AB or BA. So I'm going to label my XY, XY. Slope, remember, is the difference between your y's, so 9 minus 5, divided by the difference between my x's. So 9 minus 5 is 4. 2 minus 7 is negative 2. And 4 divided by negative 2 is negative 2. So that's the slope of BA. I want to find the slope of the line that is perpendicular to that. So remember, slopes that are perpendicular are opposite sign. So this one was negative 2, so this new slope has to be positive, and reciprocal. Negative 2. 2 is the same as 2 over 1. I'm going to change it to a fraction so I can imagine flipping that fraction. So instead of 2 over 1, it's 1 over 2. So the slope of this perpendicular bisector is going to be 1/2. Now I'm going to find the midpoint, the middle where this line is going to be. So the midpoint between A and B, I'm going to average my x's, 5 plus 7 divided by 2, and average my y's, 9 plus 5 divided by 2. So let's simplify that. 5 plus 7 is 12 divided by 2 is 6. 9 plus 5 is 14 divided by 2 is 7. So this is my x and my y point on my line. If we go over 6, up 7, we see that is my midpoint of the chord AB. So now that I have a slope and a point, I can put them into this point slope formula to write the equation of this line. So here's my perpendicular bisector. So y minus my y coordinate equals my slope, parentheses, x minus my x coordinate. So that's the equation of that line. So remember, where the perpendicular bisectors intersect is the center of our circle. So what we're basically doing, we have two equations. We are trying to find out where those two equations intersect. What point do they share in common? What solution do they share in common? Now my graph is pretty exact, so I can just look at it and say it's over 2 up 5. But if you can't, then you need to either, there's several different ways you can do it, because this is actually a system of equations. I have two equations. I'm trying to find out where they intersect or the solution they have in common. So you can go to a graphing calculator and graph them. The point where they intersect is the answer. You can convert each of these equations. You can simplify them a little bit and then use the elimination method, or you can use substitution. So there's lots of different ways that you can solve a system of equations. So solve by elimination or substitution or graphing. So I'm just going to go by graphing. That's the easiest way. It's 2, 5 is our center. So the next step is to find the radius. So I put my center there. Remember, the radius is the distance from the center to the edge anywhere. All of these points are the radius. Okay, so we can pick any one of those points, A, B, or C, and measure the distance from that point to this center, 2, 5, that we found. Now, in this case, it's a little easier. Which point looks the easiest to measure the radius? Yeah, from here to here, because notice they both have a y-coordinate of 5. It's going straight across. You don't even have to use the distance formula. You can just count and say, oh, it's 5 units. The radius is 5. But I'm going to show you, because it's not always going to be that easy, I'm going to show you how to do it. Let's pick A. So let's find the radius between 2, 5 and 5, 9 using the distance formula. So I'm going to substitute these in and see if we get 5 as well. So the difference between my x's, so I'm going to do 5 minus 2 squared plus the distance between my y's, 9 minus 5 squared. And then you just start simplifying. So always do what's in the parentheses first. 5 minus 2 is 3. 9 minus 5 is 4. Then you can do your exponents. That's 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. Then I'm going to add them. Then I can take the square root, and I see the answer is 5. So in both cases, I'm able to see the radius is 5. Now that you have the radius and you have the center, now we can substitute it into the formula to have the equation. So the center is always represented with HK. So if our center is 2, 5, that means H is 2, K is 5. And then the radius is R, which we said is 5. So I'm going to substitute those in to this format. So I have x minus 2 squared plus y minus 5 squared equals r squared. And if you want, you can go to a graphing calculator and put that in, and it will graph this circle. This is the equation of this circle.